All right, today we have the second half of lesson 8.1 on relations and functions. And we'll kind of start today right where we started yesterday with an ordered pair. And you will remember that an ordered pair is made up of two values. And the first value in an ordered pair, what do we call that?
A domain.
Okay.
Or x coordinate.
Okay, so domain is one name that we give it. We also call it the x coordinate or x value. Okay, so it's an x, it's a domain. We're going to learn another term today. And the new term that we'll learn is this, independent variable. I got to learn how to spell. Independent. Wow. Variable. All right. What does the word independent mean?
By itself.
By itself. Okay.
Like it can be
Alone. Single. Okay. Why is it by itself? Why is it single? Why is it alone?
It doesn't need something
Because
else.
it doesn't need something else. Not because we just want to put it in the corner because we don't like it, but it's independent because it doesn't need anything else for its value, for its worth. It doesn't need anything else to determine what it is. Okay, so the x value is an independent variable. It stands alone. It doesn't need anything else to determine its value. The other part of the ordered pair, what's another name we use for this?
Range.
Okay, we call it the range. What else?
Y value.
Range.
Independent.
And then the y value, and of course, since we have an independent variable, we're also going to call it,
Dependent.
this one will be a dependent variable. Okay, what does dependent mean?
It has to rely on something else.
It relies on something else. Okay. So as we look at functions today and kind of take the next step with functions, we're going to see that the x is an independent variable, that it stands alone, that it has its own value, and that the y is dependent. The y depends on the x to get its value. So if the x changes, then the y is going to change. And if the x stays the same, then the y will stay the same. Okay? Does that make sense? All right, let's look at kind of a new idea. Functions as equations. This equation here, y equals 2x plus 3, is a function. And we're not going to get into why necessarily right now. And really, this is a form of a function or a form of an equation that we're going to work with later in the chapter. But just to kind of give you an introduction to functions, think of this y equals 2x plus 3 as an equation, as a function. What happens if I know that x equals 4? What can I do then?
Plug it in.
I can plug it in and find my y value.
11.
So if I know that x equals 4, all I have to do is solve it. Y equals 2 times 4 plus 3. Y equals 8 plus 3. So therefore y equals 11. Okay? What's going to happen if I wanted to solve this equation again and I've substituted 4 back into it and I just did the whole process again, what's going to happen?
The same thing.
I'm going to get the same answer. Every time I put a 4 into the equation for x, I'll always get 11 as the answer for y, right? Okay, but what happens if I change the value for x? What happens if I decide, well, x is no longer 4, now x is 6?
And the value for y is going to change.
Then y has to change as well. Y equals 2 times 6 plus 3. So y
15.
equals 12 plus 3, which is 15. Okay? So whenever x stays the same, y stays the same. Whenever x changes, y changes, right?
Yes.
That's a function. Well, we are going to learn something called function notation. And here's how function notation works. You have this fancy squiggly little f, And for now, we can think of that as standing for function. And next to it, in parentheses, we have an x. Now, I know that typically, almost always up to this point, if you see two things next to each other with parentheses, what do you think of?
Multiply.
You think of multiplying. This is not multiplying. This is not f times x. Okay, this is function notation. It's a special way of writing things. And it means f of x. Think of it as the function of x. Okay? And in this case, it's f of x equals 2x plus 3. That's my function. My function is 2x plus 3. And then, when I see next to it f of 4, this is not f times 4, this is f of 4, I'm going to this tells me what number I'm going to substitute into the function for x. And so all I have to write then is f of 4 equals 2 times 4 plus 3. So f of 4 equals 8 plus 3, or f of 4 equals 11.
When you say of, do you mean like dividing or just of, like
Just-
for no reason?
Just of, the function of 4. What's going to happen if I plug 4 into this equation?
It will equal 11.
The function of 4 is that it will produce the result 11 every time. Okay? What's going to happen if I plug a 6 in? If I want to find f of 6, the function of 6, what's going to happen?
It will be the same answer every time.
I'm going to get a 15 because this 2x plus 3 is the same thing I had over here, 2x plus 3. So if I plug a 6 in, f of 6, I'll find that f of 6 is 15. And it will always be 15, no matter what. Okay? Yes?
So why would you like do f over like f of 4 rather than just y? Like what does it make a difference?
Because this is a special notation that we use for functions, and as we get into solving some specific kind of problems and graphing those problems, then this notation can be very helpful. Since I know that x is 4, and the function of 4 is to provide an 11 every time, I could graph that. This would be the f value, this x value, this would be the y value. I'd graph it at 4, 11, and I would know that would always be the case. Okay? There are some specific applications for function notation, and also you can do some things with functions in this form that it gets a little trickier to do it with in this form later on. We'll see. You start stacking them together and things. Let's look at some more examples. In your homework today, what you're going to see is you'll be given in the instructions for one section, you'll be given a function. So in the instructions, it'll say the function of x, or f of x, equals 4x minus 7. And then find each function value. So if f of x is 4x minus 7, what do I need to do with f of 5?
Just plug in 5 for x.
Okay, so f of 5 equals 4 times 5 minus 7. Whatever number is in parentheses next to your function indicator, you're going to plug that number into the function for x. So f of 5 equals 20 minus 7. F of 5 equals 13. And in this function, for this function, 4x minus 7, 5 will always produce a result of 13. All right, what happens here? F of negative 6 equals
4, negative 6.
4 times negative 6
Minus 7.
minus 7. Okay, so f of negative 6 equals negative 24 minus 7. F of negative 6 equals what?
Negative 31.
Negative 31. Okay? Now, the one little departure we're going to take from this way of showing functions is to understand that functions can represent a wide range of things. We could talk about distance over time. So the function of it would be like a d of t instead of f of x. Distance compared to time. So as the time increases, what's gonna happen to the distance that you're driving?
Increases.
Okay, the longer you drive, the further you go. We could talk about, dollars per hour. So the function, it would be, D of H, dollars per hour. So the more hours you work, what happens to the dollars that you earn? Okay, you earn more dollars, okay, so it doesn't always have to be f of x. It can be d of t, it can be f of h, it can be, we can fill in lots of different numbers, or letters rather, that stand for, the specific thing that we're trying to find numbers for so we can graph. Okay, so, you're also gonna have as part of your homework functions that look like this. If g of x, it's still function notation, still means the exact same thing, they're just changing the letter. So if g of x equals 3x plus 11, find each function value. So what am I gonna do for g of negative 2?
Plug in -2.
You're gonna substitute negative 2 in for x. So negative 2 plus 11. G of negative 2 equals negative 6 plus 11. G of negative 2 equals what?
5. negative
5.
Yeah, 5.
Positive 5. All right, and then finally, g of 6 equals what?
3, 6,
3 times 6 plus 11. So g of 6 equals 18 plus 11. G of 6, whoops, g of g, that doesn't work, not for what we're doing. G of 6 equals 29. All right, we good? Does this make sense?
Yeah.
It's just a new way of looking at equations, new type of equation, function notation. All you're doing is substituting numbers in for x and solving. 16 problems for your homework.